In today's lab, you're going to be determining the percent copper in a penny using a spectroscopic method called UV-vis absorption spectroscopy. So the copper in a penny is obviously elemental solid, and we need to convert that to a dissolved liquid like this that we can pass light through in order to determine how concentrated it is. So the first thing that we did was we dissolved the penny in nitric acid, which basically produced copper nitrate and zinc nitrate. Zinc nitrate's translucent to all visible colors. Copper, however, absorbs quite a bit of it, with the exception of blue. So what we're going to do is take the solution that I've made and we're going to compare it to stock solutions of known concentrations of copper nitrate. So in order to develop our standards, what we're going to do is we're going to dissolve either 1, 2, 3, 4, or 5 milliliters of 0.025 molar copper nitrate solution. Place that into a volumetric flask, and then we're going to add 5 mils of 6 molar ammonia. That's going to help the ions stay dissolved and not form a precipitate. And then we're going to fill it with distilled water up to the 25 milliliter mark. So these volumes of this molarity are going to be diluted essentially to 25 milliliters. Those are going to be standard solutions. Those are going to be your standard solutions you're going to use to determine the percent copper in your penny. So when you run your samples through the spectrometer, what's going to happen is you're going to have a blank, which is just distilled water, which, as we know, doesn't absorb any light in the visible region of the spectrum. Then your samples. I didn't label this axis because you're going to determine the molarity of each of these standards that you made, and you're going to plot those on your x-axis. Then when you run your samples through the spectrometer, you're going to get an absorption at 620 nanometers, and it should form a pretty linear function where you can get a line of best fit that's pretty accurate and not all over the place. So that's going to give you the best fit equation of y equals mx plus b, where y is the absorption, x is the concentration, and m is your molar absorptivity coefficient. I included the y-intercept here, but realistically it should come in at 0 or very close to it, because if you have no copper nitrate, you should have no absorbance. So you are going to plug in your absorption that you get when you run the sample from the penny and compare that to your curve, and you should get the molarity of the copper nitrate solution that I have produced. Remember, the penny was 2.49 grams, and I dissolved it in enough acid and then diluted it to 250 milliliters. So all of the mass of copper in the penny is now stored in a 250 milliliter volume that you're going to analyze tomorrow.